In the previous sections, I described how you can implement new functionality as standalone microservices, and you can extract modules out of your monolith and turn them into standalone services. And in both cases, you need some glue code, which is also known as an anti-corruption layer, to integrate those services back in with the monolith, because usually the data needs to be shared between the services and the monolith. So in this section, I'm going to talk more about the design of the anti-corruption layer. So it's a fancy term for glue code, and it first appeared in the book Domain-Driven Design by Eric Evans, which I've sort of mentioned is really a must-read book that's very applicable to designing microservices. So the idea first appeared there, and then it was refined in a paper that he wrote, and the link to that is on this slide. And the reason it's called anti-corruption layer is because you can think of your service code as being pristine. It has a clean model, it's written using new technology, and you want to prevent legacy concepts from polluting your nice pristine service. You want to prevent legacy concepts from corrupting the domain model of your service, hence the term corruption layer. Abstractly, the corruption layer looks like this. So on the left, we've got the service, and on the right, we've got the monolith. And then the corruption layer sits between the two. The anti-corruption layer has an API. And that's expressed in terms of the domain language of the service. So it's a pristine API into the corruption layer. And then on the other end of the anti-corruption layer is a facade, which basically wraps monolithic application functionality, and it's written in terms of the language of the monolith, so the legacy domain model concepts. And then between the two is an adapter that implements the API of the corruption layer, and then uses a translator component to translate between the two different domain models. So there's like two APIs, and then between them is a translation layer that translates from service domain model concepts into monolithic domain model concepts, and vice versa. And in some cases, the anti-corruption layer is this bidirectional layer. So one interesting issue that many people ask is, where does the anti-corruption layer reside? And another way of expressing that is, where is the remoting boundary between the service and the anti-corruption layer and the monolith? There's a few different options. One strategy is to have the anti-corruption layer as a module inside the service, and then the facade makes remote calls into the monolith. So that's one strategy. And you could think of using this when your monolith is code that you can just not change in any way, where even though you're undergoing a refactoring effort, all of the work for refactoring has to be done outside of the monolith. The other strategy is to actually put the facade inside the monolith. So we can actually, if that's code that we own, we can actually implement a facade inside the monolith to help with the refactoring effort and the implementation of these anti-corruption layers. And in this case, the adapter is making a remote call into the facade that exists inside the monolith. And then the final option is to actually put the entire anti-corruption layer inside the monolith. And so there's trade-offs. Part of it is like, how much code do you want to make? How much in the way of code changes do you want to make into the monolith? And it's like either none or more, and there's various options along that spectrum. So that's the anti-corruption layer. It's some glue code that integrates the service into the monolith so that they can share data.